So now we are going to look at a very advanced example. You can see here that we have the Raspberry Pi again. We are going to use it to implement asynchronous requests. We are going to look at how to use a decorator to simplify the handling of these type of requests. So let's begin by looking at a redesigned API for my camera. You can see here in my slide that I have created a new type of resource. Before we could take pictures with the camera and we had the photos. Now we also have time lapses. So now we will be able to send a post request to the time lapses URL, and that will request a time lapse to be generated. Now a time lapse will take by default 30 seconds. So I'm using that as an excuse to show how to make an asynchronous request. We're going to make that request return, and then we as a client will be able to get status, and we will be told when the request is completed, when the time lapse finishes, and only then we will be able to see the resource and watch the time lapse. I'm going to give you the demonstration first. I'm sure you're looking forward to that. I am. So I'm going to shell into my Pi. I'm going to change to my camera. I'm going to make sure that I have version 16 checked out. And now I'm going to start this application. Remember that this application is a single file application. I did not apply the structure. So we have only one file here, camera.py. Oh, I'm sorry. I need to activate my virtual environment first. And there we go. So now we have the API running. We are going to send a GET request to the Raspberry Pi at 10002 port 5000, asking for all the cameras. Now we are going to select the Pi. This will work with the fake camera, by the way, for those of you that don't use the Raspberry Pi, but all the pictures in the time lapse are going to be the same. They're going to be my cat. So it's not going to be very interesting to do. So here I'm going to send a GET request to the camera, and now you can see that it's telling me the photos URL as before, but it added the time lapses URL. So I'm going to copy that. I'm going to prepare this camera, make it point at me so that we can appreciate the time lapse. There we go. And now post request to time lapses. So take a look, see what happens now. I send a request. The camera LED is on. It's now taking the time lapse. It's going to take 30 seconds. The response here is 202. 202 accepted. It means that the request was accepted and it's in process. I get a location header. I'm going to send a GET request to it. This will be the URL that I use to get status. If I send a request, I get back a 202. It means that the process is still working, hasn't finished. And I can see that LED is still ongoing, so I know that this is still going. So as I keep sending updates and I get the response with the 202, I know that this task has not finished. You can see here at the end that there is a task ID. This is part of the URL, and each time there is a task, it will be different. Now I see that the LED is off, so I'm sure if I query this again, now I'm going to get the 201. So this is the response that I would have gotten if this was a synchronous request. The request will have blocked for 30 seconds, and then I will have received the 201 created and the location of my resource in the location header. So you can see that by using the 202 status code, I implemented asynchronous requests, and only once the process finished, I can get the location of my new resource. because before that it did not exist. So now I'm going to copy this URL and take it to my web browser, and let's see if we have a time lapse. So here you can see the 30-second time lapse that was taken while I was showing you the 202 responses. During this time, the API was fully functional. So for example, you could have contacted the second camera, the fake camera, and ask it to take pictures, and that would have worked just fine. The API was completely free to take on different requests. So I'm going to close this now that we finished the demonstration, exit the Pi, and I'm going to update my code here in my laptop to version 16. So let me show you, to begin, how this was implemented. I need to go to the camera directory. So you will probably expect something very complicated, but all it takes to make a request asynchronous is this. So this is what excites me the most about working with decorators with Flask. You can get great things done, and all the complexity is hidden, and you don't have to see it when you work on the important parts, which are the parts that implement the logic. So let's see a little bit of background here. The way I implemented this is in my camera class. If you remember, we had a capture method. Now I added a capture time lapse. And this is implemented by saving 30 pictures and having a sleep interval. So this is taking arguments, and this I use to specify how many pictures and what's the interval between the pictures. And this is really simple. There's nothing asynchronous here. This is done synchronously. I'm creating a file name, and as a file name I'm going to add a suffix. The suffix is going to be the picture number and the total number of pictures, and I'm gonna use that so that then I can find all those pictures that are part of one time lapse and then feed them to the browser as you saw in the demonstration. So my get new photo file name was modified to take a suffix, and this suffix I specifically created it so that I can then call format and add and replace these two placeholders with actual numbers. So there's nothing new here. I, instead of capturing one picture, do a for loop and take a picture, sleep for a bit, and then take more pictures. So let's see where all the magic is done, which is in our decorator. So the background decorator will wrap our route. This is the route that we wrote without considering any type of asynchronous behavior. We wrote it synchronously. We could have tested it synchronously and then added the background decorator to make it asynchronous. So what we are going to do in this decorator is not run that function directly. We are going to start a background thread, and then we are going to run that wrapped function, the route function, in the thread. Now, because of the context requirements of Flask, we need to ensure that the environment is proper for a route function to run. And when you need to run a Flask function outside of the original task or thread, one way to fix the environment for that to happen successfully is to copy the request context. You can write a function and decorate it with the copy current request context, which I imported from Flask. And this will set up the current request and will put a copy of it in the other task. So I wrap this function. This function will record the task in a background tasks global dictionary. I want to make sure that I keep track of all my background tasks. So this decorator uses a global variable. Same warning goes as I mentioned with the rate limiting, using global variables prevents you from using multiple workers. So that is a solution that works for small projects like what you can do in a Raspberry Pi. If you need to do something more serious, you will have to use a database so that multiple workers can see the data that you store globally. But here we have a global dictionary, and the way I'm going to work with this dictionary is as follows. When I start a background task, I'm going to assign an ID to it. And for this, I use the same technique that I use for the IDs of the photos. I create a UUID, and I use the hexadecimal version of it as my ID for the task. When I launch the thread, I'm going to put it in the global dictionary, indexed by that ID. So here I create a thread. My function for that thread is going to be this task function that is all ready to create a copy of the request context. And once I have it in the dictionary, I'm going to go ahead and start it. So this will trigger the background task to run. The first thing that it's going to do is to call make response on f. F is our original function. This is the function that takes the time lapse, our route. So this is going to run the function. The function is going to run on the background thread. The response from that will be converted into a response object with make response. And as soon as that is done, I'm going to replace the ID item, which was the thread initially, with the response that I've got from that asynchronous run in the background thread. Now, I want to make sure that there are no errors here. So just to be cautious, I put this into a try except block. I want to make sure that anything that happens here, I still return a response. So if I get any errors, I'm going to set a response that uses my internal server error helper. This is the helper that returns the 500 status code. So either way, successful or failure, I'm going to eventually have a response replacing the thread in my global dictionary. So going back to the main thread, we were running the route, we started the background thread, and now we can return the 202. This is the code that tells the client that the request is in progress, and we add a location header with a URL that they can use to get the status for the asynchronous operation. So for here, for the URL, we use a new route. Here we have one that's called get task status, and it takes an ID, and this is the ID of the task, and it's also the key in our global dictionary. So this is what gets the 202 back to the client. Now we can go see what happens when the client invokes the get task status route. So here we are not doing this asynchronously. Synchronously, we query the dictionary. We go to our background task dictionary and obtain what's stored in the ID key. If this is not, if we get no return, then that means that the task ID is false. So we return a 404. We don't know anything about this task ID. You probably realize now that we are considering our status a resource. So this is really getting the status resource for the ID. So we respond according to the not found protocol. We do the same thing that we will do with any normal resource. If we do get a value, this value could be a thread, and that means that the thread is still running, or it could be a response, and that means that the thread finished, and now we can return the response. So if it is a thread, we repeat the 202, and we include the location status URL again. Else, we know that this has to be a response. So we can go ahead and return that response as part of this request. Now, I just said a minute ago that we are considering the status tasks a resource. So the normal thing to do here will be for the client to send a new request that's using the method delete, and that will delete this temporary resource, since now that the task finished is not needed anymore. So that will be the RESTful way to handle the garbage collection of old tasks. But that could be a pain, and clients will forget to do this. Once they get the result, they're going to go happily use it. So I decided to do a little violation here of the RESTful principles, and I'm setting a configuration variable that allows me to automatically delete a status resource as soon as it is requested. So if this is enabled, and I believe I have it enabled in this example, when the client requests status and we find that the background task finished, I'm going to go ahead and remove it. So if they ask again, they are going to get not found 404. And that is the part that is not technically 100% RESTful, but I think for a case like this, it's useful to do it this way. I'm yet leaving the option to go the RESTful or 100% RESTful solution if you so desire. The last piece of this implementation has nothing to do with APIs or with asynchronous requests, but I'm sure you want to know how I managed to get the time-lapse to play on my web browser. So let's go back to my camera API documentation, the slide that I have prepared. You can see here that I decided that my time lapses are going to be returned as a multi-part response. So what this does is it enables me to, from a single request, return the list of images one after another. Multi-part is a type of response that is also used for email attachments. So if you've ever seen how emails are represented natively when you look at the headers, then you are familiar with how to include multiple files or content in a single response. So this is going to be the same, and all browsers know how to deal with this. So let's take a look at the code and see how this is done in Flask. So let's find the get time-lapse route. Here we go. So this is the route that I copy-pasted into my browser's address bar. So you can see here that I get my camera, I get my path, and then I return a response object. And instead of passing text here, I'm passing a generator. This is a Python function that will collect the images and return them in sequence. So this function is up here, and you can see that here I do a little bit of manipulation with the file names so that I can locate all the pictures that are associated with the time-lapse, and then I enter a loop. I get one and I use yield to return that picture and give it back to the client. Since the content type that I specified here is xmixed replaced, browsers know that when they get different parts in this longer response, they are going to take each part and replace the previous one with it. So I'm sending a picture, and then I wait half a second, and then I go back and send the next. And this is how you get most browsers to play an animated time-lapse. Now, there's one exception here. One browser that I know of, Chrome, does not display the time-lapse when you paste this address in the bar. But it does support this when it's embedded in an image tag. So for Chrome and possibly other browsers that I don't know about, I have implemented a second route, get time-lapse HTML, and this simply returns an image tag, and as a source in the image, there's a link to my get time-lapse route. So this is the last example that I have. I hope with all these decorator examples that I showed you, you are convinced that using them to implement the complexity in your Flask API is the best way to go. I hope you decide to play with these examples and create your own decorators. There are really a ton of ideas that I have, and I don't have time to show all of them here, so I picked a few that were significant enough, and now I expect you will go on your own and find your own solutions to your needs in your API. So with this, we conclude this class. I thank you very much for watching.